Hi guys, my name is Trevor Sullivan and welcome to another CBT Nuggets skill. In this skill, we are going to continue our learning about the Kubernetes platform, and we're going to understand how to scale applications. Now, if you've watched any of my other skills around things like deployment controllers, for example, you'll have seen that you can scale applications manually by editing your deployment manifest, or a manifest containing a replica set that's not part of a deployment, or even a resource such as a replication controller. And you can basically scale your application in a manual sense, where you're actually going in and editing the resources on your Kubernetes API server in order to increase or decrease the number of pods that are associated with a particular application. Now, typically when you are scaling pods, you are going to also have a service controller in front of that, typically a load balancer. And that load balancer is going to automatically figure out the labels of the pods that are being either scaled up or scaled down, and it will either add or remove those as endpoints from the load balancer so that traffic is properly routed to any healthy containers and pods running on your cluster. Of course, manual scaling is one way to accomplish scaling of your pods on Kubernetes. However, you are probably going to quickly run into situations where you want to automate the scaling of the pods within a given application. This holds true especially if you're running many different applications on your cluster. You've probably got different namespaces for different teams. Maybe you've got a website namespace for your company's business website that's public facing out there on the internet, and then maybe you've got other namespaces for other application developers to deploy their applications into. And each of those development teams is probably going to have different needs for scaling their specific application components on a Kubernetes cluster. So what we're going to do is take a look at how to use a few different types of scaling. In particular, we're going to focus on the horizontal pod scaler for now, but at a high level, I wanted to kind of cover some of these other options that you have for scaling pods on a Kubernetes cluster as well. Now, remember, keep in mind that scaling pods on Kubernetes ultimately has the end goal, the objective of improving user experience. So if you have users that are hitting an application, again, such as your business website, like this little pod right over here, then you are going to need to scale depending on how many users are simultaneously hitting that application, and oftentimes other metrics like how much CPU and memory the pods are experiencing individually, or how much they're actually consuming individually. And then you can kind of set like a target of how much CPU usage overall you want each of your pods to have, and then you can use that as a determining factor whether you should scale up the number of pods in your application or whether you can scale it down and still maintain the same level of performance for your end users. But again, the end objective here is really to ensure that as our end users are replicating here, that we are able to satisfy the demand that these users are putting on our application. Now, the reason that you might want auto scaling is so that you don't have your different components kind of competing with each other for resources. Now, take, for example, a service like maybe a doctor's office, right? They're scheduling appointments during the day, they're putting in notes for patients and things like that. And so they're going to have pretty heavy usage on their health application, their internal health application. What do they call it? Electronic medical records, EMR, I think. And that application in particular is going to have higher usage during the day. Whereas if you have a hospital that's operating 24 hours a day, then that emergency room application might have much heavier usage throughout the course of the day. And so by setting up auto-scaling rules, we can ensure that the applications and the number of pods that are supporting each of those applications can automatically scale without us personally having to get involved every single time that it turns 5 o'clock and the doctor's office shuts down, for example, or it becomes 8 a.m. and the doctor's office opens up and then we need to manually scale it. By automating the scaling, we can take that human factor out of the equation. Now, Kubernetes has a few different constructs that are useful for scaling applications as well as the actual infrastructure that is supporting your cluster. So at a high level, we have the cluster scaler, the vertical autoscaler, as well as the horizontal pod autoscaler. And each of these have kind of different purposes for when you'd want to use them. Now, if you're cluster, which is right over here. We've got, of course, an array of master nodes, and we've got an array of worker nodes that typically make up your Kubernetes cluster. In cloud platforms like Amazon Web Services or Google Kubernetes Engine or Azure Kubernetes Service, you often see references to things like node pools, and those node pools are representative of the worker nodes that are actually running pods on the cluster, whereas the master nodes are typically the control plane nodes that are managed by the cloud provider's managed service, like Elastic Kubernetes Service in AWS. Those master nodes are kind of opaque to you. You don't really see them. So because you don't actually see those master nodes, you don't really need to worry about scaling them. That's all handled for you by the cloud provider. But these worker nodes that are actually running the pods for your different applications, that's really where we are going to need to worry about, scaling up or scaling down the number of worker nodes that we have. So in the event that we run out of capacity on our cluster here, we might need to spin up another node in our cluster just to add additional CPU and additional memory resources to run our application pods. And then if we really see a spike in traffic, then we might need to add a whole bunch more nodes. So maybe we'll, add 3 more worker nodes here and increase that node pool by a significant amount. And then on the flip side, if we ended up needing to scale down, we could actually terminate some of those worker nodes and thereby reduce our cost that we are spending on compute nodes in our Kubernetes cluster in the cloud. I mean, that's one of the core benefits of cloud technologies, is that you have the elasticity of the cloud where you're only paying for the resources that you're actually using. If you need more capacity, that capacity is available in the cloud vendor's data centers, and you can simply request that capacity and scale up your compute nodes. And in the event that you don't need that capacity anymore, you can just give it back to the platform and somebody else is able to use that, or it just remains as spare capacity in the cloud provider's data centers. So that's kind of cluster scaling, is the need to kind of increase the number of worker nodes in your Kubernetes cluster. And then we also have the concept of vertical autoscaling. And so this is where you might have pods, and a pod might have, let's say, 200 millishares of a CPU core, and maybe that application, in order to run efficiently, it actually needs access to 600 millishares of a CPU. And so the vertical autoscaler is actually a component that you can install into your cluster. It doesn't come out of the box with Kubernetes, but it is something that you can install into your cluster very easily. And then that vertical autoscaler can actually go out and increase the resources that a given pod running on your cluster has allocated to it. So it can actually change the configuration of a pod basically by replacing the pod. So you can't actually change the resource limits on a pod, but you can replace the pod with a new pod running the same container image, but you can change the request shares on the CPU as well as the memory that that pod is requesting from your cluster nodes down here. So the vertical autoscaler will automate handling the cleanup of any pods that don't have appropriate resources allocated to them, as well as replacing them with new pods that do have the appropriate request limits assigned to them. And then finally, we've got the autoscaler for horizontal pod scaling. And this, as the name implies, scales pods horizontally. So rather than vertically scaling a pod where we increase the number of CPU and memory resources that are associated with that pod, what the horizontal pod scaler does is it actually just increases the number of pods that are available for a given application component. So if you have a deployment controller, for example, then your deployment controller can have the horizontal pod scaler automatically spin up additional pods in order to support an application that's overloaded. So this is what we're going to spend the most of our time on here, is this horizontal pod scaler, and understand exactly how to configure that resource, because it does come out of the box with a Kubernetes cluster in Amazon EKS. And we can configure that horizontal pod scaler resource to increase the number of pods in our application. So this is very similar in some sense to the cluster scaler, because what the cluster scaler is doing is it is increasing the number of nodes that are in your node pool for your Kubernetes cluster. And in a similar vein, the horizontal pod scaler is going to basically increase the number of pods that are associated with a given application. So if you have one pod running your website right here, and you've got a bunch of end users hammering that website, you can actually have the horizontal pod autoscaler go out to the controller for this pod and actually increase the number of pods and create additional replicas of those pods to support the application. And then the service controller will automatically rebalance the endpoints across all of these pods so that your users have a much better experience. So let's take a look at how the horizontal pod scaler works on a brand new cluster using the Amazon EKS or Elastic Kubernetes service. However, these concepts should more or less replicate over to other cloud vendors like Google Kubernetes Engine or Azure Kubernetes Service. I hope this has been informative for you, and I'd like to thank you for viewing.